In this video, we're going to be proving the change of base formula, and we're also going to do a quick approximation of a logarithmic equation. We're going to start with our proving of the change of base formula. So we have the log base a of x equals the log base b of x divided by the log base b of a. So that's our change of base formula. So we're going to start with the left side, and we're going to turn it into the right side. So we're going to begin by saying y equals the log base a of x. From there, we're going to rewrite it as an exponential. So an exponential form. So a to the y equals x. Now our point is to try and make it turn into our change of base formula. So we want to think about, gosh, how can I get the other logs there? And so I can take the log of both sides here. So if I take the log base b of both sides, I'm still keeping my equation equal because I've done the same thing to each side. Now, we know that for exponents, we can write those in the front of our logarithms. So we're going to take our y and pull it to the front, giving us y equals the log base b of a equals the log base b of x. From here, I can separate my log base b of a from y by dividing both sides by the log base b of a. That will eliminate it on the left-hand side, leaving us with y equals the log base b of x divided by the log base b of a. So now we ask ourselves, well, what does y equal? Well, y, remember we said that was the log base a of x. So if we plug that in, that gives us the log base a of x equals the log base b of x divided by the log base b of a, which is what we were looking for. Now, let's do a quick approximation of a logarithmic equation. If I have the natural log of x equals x squared minus 2, and I'm evaluating that, I'm going to need to use my calculator. But in order to do that, I need everything on the same side. So we're going to take our natural log of x, which is x squared minus 2, or set equal to that, and we're going to subtract our x squared and subtract our 2 from both sides, which is going to give us negative x squared minus 2 plus the natural log of x. So to finish evaluating or approximating the solution, we're going to need our graphing calculator. So we're going to plug in our equation, negative x squared minus 2 plus the natural log of x. I'm going to check my window from before, and it looks like I'm going from negative 3 to 5 and negative 3 to 5, which might be okay. So we're going to go ahead and we're going to plug it in, and we're going to check it, and if not, we can adjust our window as needed. If your window says 10 by 10, you might find that you need to zoom in or that you need to zoom back out in order to see your solution. So I'm going to go ahead and graph this, and it looks like we can't quite see it. So I'm going to come back to my equation and check it and just make sure that I have it plugged in right. And I'm going to see that looks like that's plugged in right, but as I look at my math, I'm catching a mistake that you guys probably already caught, that instead of subtracting that 2, I really should have added that 2 to the other side. That's going to make a big difference for us. So that should be a plus 2 there. So now let's go back to our calculator and make that quick adjustment of a plus 2 and hit graph. And there we go. That's a little bit better. Now we can see our solutions here and here. So to approximate those, we're going to use the calculate feature for our graphing, which is with our trace button. So we're going to hit second, trace, and we're going to calculate the zeros. So we're going to calculate our left zero first. So we're going to be on the left-hand side, so below it, on the left-hand side, and then we'll move to the right of it. And we see that our zero fits between those two tiny lines that we have. And we hit enter to engage, and it says 0.1379. And so if we're to round that to 3 decimal places, that looks like a 0.138. So we'll write that down as one of our solutions, and we'll do the same thing again to get our other 0. So we'll go second, trace, to our 0 feature, and we'll go on the left-hand side and hit enter, and onto the right-hand side, and we'll double check and make sure that our 0 is between those two pieces, and hit enter. And here we get 1.5644. So rounding that to 3 decimal places is going to be a 1.564 for our solution. So we'll write that down. And now we still need to check our solutions. So we'll need to plug those in. So we're going to check them. So the natural log of our value equals our value squared minus 2. So we'll start off by checking our 0.138. And when we plug that in, that's going to give us a value of approximately negative 1.9805 and negative 1.9810. And those are pretty reasonable, pretty close. If we were to round out to 3 decimal spots, we would be the same spot, so that works. And now we'll try our natural log of 1.564 and see if that in fact equals 1.564 squared minus 2. And when we plug that into the calculator, we're going to get 0.4472 and 0.4461. And although the first three wouldn't match, that's actually really reasonable. And so we're able to, in fact, say that these are our solutions.